certain composite functions. Look at here. When we have sine inverse, by the way, sine inverse of x is sometimes called as arc sine x. Okay, but we will use sine inverse x in this course instead of arc sine x. And what happens is sine inverse of sine x will be x as long as this x is in between negative pi over 2 and pi over 2. Okay, what happens if x is outside of this interval? Yeah, we'll talk about that later. Similarly, sine of sine inverse x will be x if this x is in between negative 1 and 1, and so on. So let's look at these examples. In part A, we have sine inverse of sine pi over 4. It's like here, and x is in between negative pi over 2 and pi over 2. Okay, so we have to have negative pi over 2 to pi over 2, and 1/4 pi is somewhere here. So by using this first rule, sine inverse of sine x is simply x, because our x is in between negative pi over 2 and pi over 2. Next, sine inverse of sine pi over 6 is about the same, but unfortunately 5 pi over 6 is bigger than half pi, so it will be outside. So this is not simply pi over 6. Now we need to go look at the unit circle and find the equivalent value of sine pi over 6 equals sine of some angle which is in between negative pi over 2 to pi over 2. As we know, when we studied unit circle, we know that sine of pi over 6 has same value as sine pi over 6. Okay, pi over 6, pi over 6 have the same value for sine, because sine is positive in both quadrants. So this is same as sine inverse of sine pi over 6. Then now we can apply the first property. Sine inverse of sine x is just x, because our x is now in between negative pi over 2 to pi over 2. Part C, cosine inverse of sine 3 pi over 4. Okay, I meant cosine here. And using the same rule like here, cosine inverse of cosine x is x, as long as this x is in between 0 and pi. So 3 pi over 4 is in between 0 and pi. So this is simply 3 pi over 4. Okay. Part D, cosine inverse of cosine 7 pi over 6. It's about the same as C, but this is outside of pi. Okay, this is 7 pi over 6 is bigger than pi. So we cannot simply write answer as 7 pi over 6. This is wrong. So what we do here is we do like part B. Okay, so let's do this. We know that pi over 6, pi over 6 are kind of related angles, and 7 pi over 6, that's in third quadrant, and cosine 7 pi over 6 has negative value, and same as cosine pi over 6, it has negative value as well. So cosine 7 pi over 6 is same as cosine pi over 6. Okay, they have the same values. How does this help now? Now pi over 6 is in between 0 and pi. Okay, here, so we can apply this rule. Cosine inverse cosine cancel, pi over 6. Part E, cosine inverse of cosine negative angle. We learned earlier that cosine is an even function, so cosine of negative angle is same as cosine of positive angle. Okay, just pi over 5. And pi over 5 is in between 0 and pi, so we can simply apply this rule. Cosine inverse cosine cancel, pi over 5. Okay, and In the same way, let's do part F. Part F, tangent inverse of tangent angle. Look at this rule. Tangent inverse of tangent x is x as long as this x is in between negative pi over 2 to pi over 2. But 4 pi over 5 is bigger than pi over 2. Okay, it's like in second quadrant, and we know that when we have angle theta, this is pi minus theta, so 4 pi over 5 has same value as pi over 5 plus minus different, and tangent is negative here, 4 pi over 5 here, negative pi over 5. Now tangent has negative value here and here, so 4 pi over 5 is same as negative pi over 5. So we are looking from negative pi over 2 to pi over 2. So this is same as tangent inverse of tangent 4 pi over 5 is tangent negative pi over 5. Now we can apply the first rule, and the final answer is just negative pi over 5. Final.